Under the Antarctic ice sheet lies a continent the size of Australia, with a complex relief featuring mountain ranges up to 3,000 meters high, deep valleys, and vast plains. This hidden world, completely isolated from the rest of the planet, is a unique ecosystem where ice covers not only mountain ranges but also mysterious lakes, such as Lake Vostok, which is located 4 kilometers beneath the ice. In this lake, which is over 100 kilometers long, microorganisms have been found that could survive in conditions far removed from those familiar to us. The landscape, if it could be seen, would be breathtaking. The contrast between dark rocks rising above the light ice plains and frozen river channels creating intricate natural patterns. Due to extreme conditions, air temperatures can drop to -80 degrees Celsius, and winds can reach speeds of up to 200 kilometers per hour, creating real ice storms. It is worth noting that only 15% of Antarctica's territory consists of polar ice deserts, while the rest hides beneath it picturesque mountain ranges, such as the Birdmore Mountains, which are part of the Antarctic Alps. These mountains have been formed over millions of years as tectonic plates shifted, creating remarkable natural formations. Antarctica also has unique geological structures, such as the volcanic massif of Erebus, one of the most active volcanoes on the planet. It constantly releases gases and steam, creating a mystical atmosphere around it. Scientists from various countries, including the United States and Russia, are actively studying this continent using the latest technologies, such as radar research, which allows them to peer into the depths of the ice cover and study its structure. Research shows that beneath the ice are not only frozen lakes, but also complex systems of underground rivers that can affect global sea levels. Additionally, climate change around the world is leading to the melting of glaciers, opening up new opportunities for studying this isolated ecosystem. In recent decades, scientists have discovered that some species of animals, such as Antarctic penguins, have adapted to extreme conditions and managed to survive in this harsh climate, challenging our understanding of the boundaries of life on Earth. The unique nature of Antarctica is also home to species such as seals and seabirds that depend on this icy environment for reproduction and feeding. Each year, researchers uncover new facts that confirm that Antarctica is not just an icy wasteland, but a complex and fascinating ecosystem with rich biodiversity. It is important to understand that this is not just a piece of land, but the key to understanding global climate and its changes. Each new fact discovered by scientists adds another detail to this complex picture. Beneath the thick ice of Antarctica lie truly extraordinary worlds that humanity is just beginning to comprehend. One of the most striking discoveries is Lake Vostok, located under an ice sheet covering an area of approximately 1 million square kilometers. This lake, comparable in size to Lake Ontario, stretches over 250 kilometers in length and reaches a depth of more than 900 meters. Its discovery became possible thanks to radar studies conducted by an international team of scientists in the early 2000s. Using radars, researchers were able to detect subglacial bodies of water that had remained hidden from human eyes for millions of years. The water in these ancient lakes remains liquid due to geothermal heat emanating from the Earth and the pressure exerted by the multi-kilometer layer of ice above. This creates unique conditions where life could evolve in the absence of light and oxygen, opening new horizons for biological research. Russian and American scientists working on the Lake Vostok project successfully drilled through the icy crust in 2011 and gained access to water that, according to preliminary studies, contains microorganisms adapted to extreme conditions. These findings raise numerous questions about how life can exist in such conditions and what secrets these isolated water worlds hold. Studies show that the temperature of the water in Lake Vostok reaches -36 degrees Celsius, yet it remains in a liquid state. This remarkable anomaly is the result of complex ecological and geological processes that have been occurring over millions of years. Similar subglacial bodies of water, as recent research indicates, may not be unique to Antarctica. There may be many such lakes. The discovery of even one of them opens new horizons in understanding our planet and potentially changes our understanding of the possibility of life on other planets, such as Europa, a moon of Jupiter, where there are also subglacial oceans. Research shows that in these isolated ecosystems, there exists a unique set of biological species that could have evolved in conditions of complete absence of light and oxygen. Scientists working in Antarctica continue to study these water bodies, striving to unravel their mysteries and understand how life can survive in conditions that seem completely inhospitable. This discovery becomes an important step in the study not only of our planet, but also of other celestial bodies in the solar system. Antarctica is not just a cold continent, it is a gigantic reservoir of fresh water containing approximately 70% of all the fresh water on our planet in the form of ice. If we imagine that all this ice were to melt, the global ocean level would rise by as much as 58 to 60 meters. This would be equivalent to entire cities, like New York or Tokyo, being submerged underwater. The ice in Antarctica, formed over millions of years, contains crystal clear water that has no equivalent on Earth. This water has been preserved in a frozen state, protected from external influences, and when it melts, it becomes incredibly transparent, almost like glass, allowing one to see the depths of ice caves and crevices. Light passing through the ice masses is refracted, creating unique shades of blue and turquoise that captivate with their splendor. Scientists like Dr. Jeffrey Butt from the Polar Research Institute study ice samples to understand climate changes over the past thousands of years and to determine how temperature changes affect ocean levels. This research is critically important because Antarctica influences global climate processes. The ice shields covering this continent can reach thicknesses of more than 4 kilometers in some places, and their dynamics under the influence of global warming are causing increasing concern among climatologists. It is crucial to remember that every cubic meter of melted ice can have consequences for coastal ecosystems and cities worldwide. In Antarctica, ice is not just frozen water. It is a true history of Earth, recorded in layers that scientists analyze to predict our future. Special drilling systems, such as the Crown system, allow for the extraction of ice samples from depths of up to 2 kilometers, opening new horizons in understanding climate changes. Each sample can contain air bubbles that have preserved the atmospheric conditions of ancient epochs, providing a unique opportunity to study the past of our planet. Imagine a world where the melting of Antarctic ice leads to a rise in sea level by several meters. This is not just a theoretical scenario, but a real threat that could become a reality in the next few hundred years if the current trend of global warming continues. Coastal cities like Amsterdam, located below sea level, will be at risk of complete flooding. The Netherlands, with their complex system of dams and canals, may disappear from the world map if the water level rises by just 2 meters. The situation in Bangladesh will be even more catastrophic. With a population density of over 1,000 people per square kilometer, millions will be forced to leave their homes when water floods the vast lowlands that make up a significant part of the country. Venice, famous for its canals and historical architecture, will become a victim of its own charm when the water level rises, flooding squares that were once centers of culture and trade. St. Petersburg, built on marshy land, will also be at risk. Many of its famous embankments will be underwater, and historical buildings like the Church of St. Isaac may become inaccessible to future generations. New Orleans, a city already struggling with floods, will have to fight against waves that will come every year, bringing salt water that will destructively affect freshwater bodies and ecosystems. The sounds of retreating and advancing water will be accompanied by a roar reminding us that nature does not forgive human errors. The salty smell penetrating deep into the continents will remind us that life on Earth is changing. New shorelines will be determined not only by the water level, but also by how humanity adapts to these changes. These transformations will not happen instantaneously. They will develop over many centuries, but the consequences will be irreversible. Entire countries may disappear, and familiar landscapes will change beyond recognition, leaving us only memories of how our planet once looked. According to estimates, if the sea level rises by 1 meter, it will affect more than 100 million people worldwide, and if it rises by 2 meters, the number of affected people could double. Antarctic ice is not just frozen water, but a complex system that holds the history of our planet. This ice is primarily made up of frozen fresh water, but beneath its surface lie tiny air bubbles that serve as time capsules. Each bubble is a remnant of the atmosphere that once existed, allowing scientists to learn about past climatic conditions, the composition of the atmosphere, and even events that occurred thousands and hundreds of thousands of years ago. The formation of ice in Antarctica begins with snow falling on the continent's surface. With each new layer covering the old one, the snow gradually compacts under its own weight. It first turns into firn, a semi-transparent mass, that eventually becomes true ice. This process can take thousands of years, resulting in an ice layer several kilometers thick. Research shows that in some places the ice thickness exceeds 3 kilometers. When ice cores are extracted from the depths, researchers find not only air bubbles, but also particles of dust, volcanic ash, and other materials that traveled through the air in ancient times. For example, in samples collected in the West Antarctic region, scientists discovered traces of volcanic eruptions that occurred more than 80,000 years ago. These particles provide valuable insights into how volcanic activity influenced past climate changes. Each layer of ice we study is like a roadmap, showing how the atmosphere changed and what events affected climatic conditions. The study of these samples has allowed scientists to determine that the level of carbon dioxide in the atmosphere was twice as low as it is today, offering a unique opportunity to understand how the climate responded to natural changes. It is important to note that the process of extracting ice cores involves complex technologies, such as specialized drilling equipment, which helps minimize contamination of the samples. In the end, every drop of Antarctic ice is not just water. It is a true library containing information about millions of years of Earth's history. Approximately 34 million years ago, when Antarctica separated from the supercontinent Gondwana and began its journey towards the South Pole, the climate on Earth underwent significant changes. During this period, the temperature on the continent gradually decreased, leading to transformations in the ecosystems that were once teeming with life. The forests that once densely covered the territory of the modern continent began to be replaced by colder and harsher landscapes. Scientists suggest that at that time, Antarctica was home to various species of flora and fauna, including coniferous trees and even mammals, such as the ancestors of modern seals. With each passing million years, the temperature continued to drop, and in place of the lush forests, tundras and then ice deserts began to form, which today characterize this region. The appearance of the first glaciers became noticeable around 28 million years ago when ice caps began to form in the mountains and gradually descended into the valleys. This process lasted for millions of years. Glaciers, slowly moving under their own weight, captured new territories, increasing their area until a continuous ice shield emerged, which today covers a large part of the continent. Around 15 million years ago, the ice cover reached its maximum extent, and its thickness in some places exceeded 3 kilometers. This was the time when Antarctica became an ice continent, playing a key role in the global climate. The ice shield not only reflected sunlight but also influenced ocean currents, which in turn altered the climatic conditions on all continents. Observing this slow but inexorable process, we can only imagine how life changed and adapted to new conditions. Each layer of ice accumulated over millions of years has become a kind of archive, preserving data on climate, atmosphere, and ecosystems that existed in the past. Studying ice samples, scientists can reconstruct the climatic conditions that existed in different epochs, which allows us to better understand how current climate changes may affect our planet. Today, the ice shield of Antarctica covers an area of approximately 14 million square kilometers, which is about 90% of the entire surface of the continent. The ice shield of Antarctica is a complex and dynamic system consisting of the eastern and western shields, each with its own unique characteristics and behavior. The eastern shield, covering approximately 72% of the entire ice cover, is significantly thicker and more stable than its western counterpart, which is subject to faster melting. The western shield, in turn, contains ice streams that rapidly move towards the ocean, creating ice shelves that can reach several hundred meters in thickness. These ice flows move at speeds ranging from several centimeters to 3 meters per year, making them some of the most rapidly changing areas on the planet. When viewed from a bird's-eye view, these ice streams resemble slow-moving rivers winding across the snow-white plateau, leaving behind deep cracks and fractures that give this landscape a unique beauty. Moving ice produces characteristic sounds, creaking and groaning, as if the Earth itself is whispering about its internal processes. Deep rumbles, occurring when massive ice masses move, can resemble the distant thunder of a storm. These sounds and sights create a unique atmosphere where one feels the power and majesty of nature. Ice streams, like living beings, constantly change. They can accelerate under the influence of climate change or slow down due to temperature fluctuations. Over the past 30 years, scientists have recorded a significant increase in the speed of some streams, such as the Totten Stream, which is moving towards the ocean at an accelerating pace, threatening to raise sea levels. Relatively recently, in 2006, scientists recorded that the West Antarctic ice sheet is losing around 12 billion tons of ice per year, which is a worrying sign for the entire Earth's climate. Antarctica is not just an icy continent, it is a key element of Earth's climate system. The cold air that forms over its vast ice cover creates powerful winds that shape circulation patterns affecting the entire planet's climate. These winds, known as polar vortices, can transport cold air over long distances, causing significant temperature changes in other regions. For instance, in 2008, researchers from the Scripps Institution of Oceanography found that a drop in temperature in Antarctica by a few degrees could trigger an unusually warm winter in Europe and North America. Alongside atmospheric changes, cold bottom waters form around Antarctica, playing a vital role in the global ocean. These waters, formed by cooling and heat loss from glaciers, sink to the ocean floor and begin their journey through the world ocean. They become part of the global conveyor belt of ocean currents, known as the thermohaline circulation, which connects all the oceans. This circulation system regulates climate conditions, distributing heat and nutrients worldwide. For example, cold waters leaving Antarctica affect the temperature and salinity of waters in the Atlantic Ocean, which can in turn lead to changes in marine ecosystems. Scientific research shows that even small changes in Antarctica's ice cover can have catastrophic consequences. In 2009, scientists from the University of California, Los Angeles, predicted that if the rate of ice melt continues to accelerate, sea levels could rise by more than 1 meter by the end of the 21st century. This threatens the flooding of coastal cities such as Mumbai, New York, and even St. Petersburg. The interaction of cold Antarctic waters and warm equatorial currents can alter rainfall patterns, leading to droughts in some regions and floods in others. Thus, Antarctica, isolated in its icy realm, has endless connections with the rest of the world. Every change in its ice cover echoes in the most distant corners of the Earth, influencing ecosystems, climate, and even human life. These processes demonstrate that the planet is a unified system where each element plays its role. In the 21st century, we continue to explore how Antarctic glaciers and their dynamics can determine our future climate. For example, research conducted in 2020 confirmed that the speed of ice melt in Western Antarctica has increased by 80% compared to the previous 3 decades. Snowflakes landing on the surface of Antarctica embark on a long journey of transformation into ice, a process that is remarkable in its complexity. Initially, the fluffy snow with its lightness and airiness gradually loses its lace-like structure under the pressure of new layers. Each year, up to 2 meters of snow accumulate, and under this weight, snowflakes compress, turning into granular firn. Firn is an intermediate stage between snow and ice, with a density of around 130 kilograms per cubic meter, compared to the 30 kilograms per cubic meter of freshly fallen snow. The compaction process takes decades and sometimes even centuries as snow accumulates and compacts, transforming into ice. At this stage, firn, which is initially white, begins to acquire light blue hues. This is due to the removal of air bubbles contained in the snowflakes during compression and compaction, allowing light to pass through the material and creating unique optical effects. Firn then continues to compact into crystalline ice, which has a density of around 900 kilograms per cubic meter. This process can take from 10 to 100 years, depending on climatic conditions and the thickness of the snow cover. When ice reaches its final stage, it becomes transparent, with its color ranging from pale blue to deep blue, depending on the amount of air bubbles and impurities it contains. The oldest layers of ice in Antarctica can reach an age of up to 80,000 years, preserving records of past climates. These ancient ice cores become true archives of climatic changes, allowing scientists to study atmospheric conditions and air composition from distant past epochs. Under pressure, ice becomes not just frozen water, but a true natural wonder that holds the secrets of many epochs. When snow falls on the surface of Antarctica, it gradually turns into ice, and the layers that accumulate can reach 3 to 4 kilometers in height. This weight creates immense pressure that forces air out of the crystal lattice of the ice. As a result, denser and more stable ice forms, which can have different crystal structures depending on the depth. At shallow depths, ice may have a structure resembling ordinary crystals, but as it is pressed and the temperature changes, the ice becomes denser, forming more complex structures like Ice 7, which exists only under extremely high pressure. The processes occurring within the ice are invisible to the eye, but they are crucial for understanding Earth's climate. At the depth of the ice sheet, temperatures can reach -5 degrees Celsius, but under pressure and due to geothermal heat, they can rise, sometimes reaching the melting point of ice. This phenomenon leads to the formation of subglacial lakes, such as Lake Vostok, which is located more than 3 kilometers beneath the ice. These lakes have been isolated from the outside world for millions of years and can contain unique forms of life adapted to extreme conditions. Research conducted by scientists, such as a team from Russia and the United States in 2011, showed that even in such conditions, microbial organisms can survive in complete darkness and high pressure. The structure of ice under pressure and temperature becomes a true reflection of our planet's history, preserving data on the climatic changes that have occurred on Earth over millions of years. The ice cover of Antarctica is not just a frozen state, but a genuine time capsule preserving ancient landscapes about which we can only speculate. Beneath layers of ice reaching over 3 kilometers in places, there are mountains, valleys, and lakes that existed millions of years ago. For instance, a study conducted in 2015 by a group of scientists from Dalhousie University revealed that some of these ancient landforms have remained unchanged since the onset of glaciation, which began around 30 million years ago. They have retained their shapes and features, as if frozen in time when Earth looked entirely different. One such valley, known as the Sanders Valley, was discovered precisely because of the ice deposits that carefully sealed it, preserving it in its original state. Scientists note that such places allow us to peer into the past and understand how the climate and landscape of our planet have changed. Research conducted in 2010 showed that beneath the ice layers lie not only geological formations but also traces of ancient ecosystems, opening doors to understanding the biodiversity that existed before glaciation. The restoration of these landscapes using satellite technologies, such as radars and laser interferometry, has allowed for the creation of precise three-dimensional models that shed light on the geological history of the region. These models show how rivers flowed, how lakes formed, and what shapes the mountains took when the climate was warmer. For example, the Lake Vostok, located under the ice cover, is one of the largest subglacial lakes in the world and preserves a unique ecosystem that has existed in isolation for millions of years. The study of these ancient landscapes not only helps us understand what Antarctica looked like before glaciation, but also provides insights into how climate changes can affect ecosystems in the future. In 2009, researchers from the National Science Foundation of the United States discovered traces of ancient ecosystems that existed on this continent before it was fully glaciated, opening new horizons for understanding the biological history of the planet. Each layer of ice is an archive, storing information about the climatic conditions that once prevailed on Earth, and studying these data helps predict how the climate may change in the future. It's hard to believe, but millions of years ago, Antarctica was part of a lush world where tropical forests thrived and the climate was warm and humid. This part of the Earth was once part of the supercontinent Gondwana, which united South America, Africa, India, and Australia. Around 100 million years ago, during the Cretaceous period, coniferous trees like the horsetail and araucaria grew in the area now known as Antarctica, forming dense forests that filled the air with the scent of resin and freshness. Continuous tropical rains created ideal conditions for growth, and the ecosystems were rich in biodiversity. Dinosaurs, mammals, and primitive reptiles, as well as a multitude of insects, were attracted to the vibrant flowers and fruits. Around 80 million years ago, as Gondwana began to break apart, Antarctica started its slow drift towards the South Pole. This process was not instantaneous. Over millions of years, the continent gradually isolated itself from other landmasses, leading to a change in climate. Initially, the warm and humid climate gave way to harsher conditions as forests thinned and gave way to grasslands. Around 40 million years ago, during the Eocene epoch, Antarctica was already covered in an ice sheet that continued to grow, creating vast expanses of ice that now cover a significant portion of the continent. Studies of samples taken from the depths of the ice show that in those distant times, the climate was more diverse than it is now, and this contrast helps us better understand how the climate on our planet has changed. Ancient Polynesians who explored the southern seas probably had no idea about the existence of this frozen desert, but now that we know about its past, it becomes clear how unusual Antarctica was before it became what we know it as today. Currently, the area of Antarctic ice sheets is approximately 13 million square kilometers, and in some places the thickness of the ice exceeds 4 kilometers. Once upon a time, Antarctica was a completely different place, teeming with life and vibrant colors. Fossils found in this icy, desolate region testify to the fact that a warm climate once reigned here. In particular, in 1971, a team of paleontologists led by Dr. Robert McCallum discovered dinosaur remains in the Transantarctic Mountains. These fossils belong to a family of predatory dinosaurs resembling modern lizards but much larger in size. They could reach lengths of up to 20 meters and weigh more than 10 tons. Their diet included herbivorous dinosaurs such as ankylosaurs, which likely emitted low, muffled sounds in an attempt to scare off predators. In addition to dinosaurs, researchers also found fossils of ancient ferns called Glossopteris. These plants, which could reach heights of up to 20 meters, had broad leaves that formed dense forests, creating shade and coolness on the ground. Glossopteris was an important part of the ecosystem, providing food for many creatures and releasing oxygen into the atmosphere. They thrived in the warm, humid climate that existed on the continent at the time and filled the air with a sweet aroma. It is no wonder that paleobotanists, studying these finds, describe this period as a time of lush life. In Antarctica, there were also coniferous trees that could reach heights of 40 meters and shrubs covered in bright flowers. Birds, the ancestors of modern ones, soared over this green world, emitting melodious sounds, while animals, resembling mammals, moved silently through the undergrowth, leaving tracks in the soft soil. While today Antarctica is covered in cold and silence, in the past it was a place of life that could have astonished any traveler. These fossil finds show that Antarctica was located in more northerly latitudes, which explains the presence of exotic flora and fauna. For example, in 1989, in the area of Seymour Island, remains of marine reptiles such as plesiosaurs were discovered. These creatures swam in the warm waters of the ancient ocean and could reach lengths of up to 7 meters, with long necks and heads resembling sea turtles. They hunted fish and mollusks, filling the waters with the sounds of splashing and crunching. Climate changes that occurred millions of years ago led to Antarctica's descent into an icy silence. As the continent moved southward, temperatures dropped and the ecosystem changed. Scientific research shows that around 70 million years ago, when the climate became colder, Glossopteris and other heat-loving species began to go extinct. This change in climate led to significant changes in the region's biodiversity. Today, Antarctica is home to animals such as penguins and seals, which have adapted to extreme conditions. However, the fossils found in this region remind us that once there was a completely different life. In the area of the Transantarctic Mountains, not only dinosaur remains, but also traces of ancient ecosystems that once covered this continent were found. These discoveries provide scientists with a unique opportunity to reconstruct the nature that existed on the territory of Antarctica millions of years ago and to understand how climate changes can affect ecosystems. It is important to remember that each new discovery contributes to our understanding of the history of life on Earth. Antarctica, once a flourishing continent, has undergone colossal changes that have left an indelible mark on its history. Around 34 million years ago, a prolonged cooling process began, leading to the formation of the first ice sheets in the mountainous regions of the continent. This transition was not sudden, but stretched over millions of years as the climate gradually became harsher. Forests that once covered Antarctica began to retreat, giving way to open plains and cold deserts. Research shows that at the end of the Eocene epoch, when temperatures significantly dropped, the continent's ecosystem began to change. At that time, various animal and plant species, including ancient ferns and conifers, inhabited Antarctica. As the climate cooled, the soil froze, and the level of carbon dioxide in the atmosphere decreased, contributing to the extinction of many species. This was a time when animals began to migrate to warmer regions or perish in conditions that became increasingly inhospitable. Around 14 million years ago, the final transition to glaciation occurred. Ice sheets began to cover the entire continent, forming massive ice shields. These ice sheets reached thicknesses of up to 4 kilometers and shaped the landscape we see today. During this period, the surface temperature of the Earth fell below zero, and Antarctica became one of the coldest places on the planet. The ice caps formed as a result of this process became key elements of the global climate system, influencing sea levels and climatic conditions worldwide. The glaciation, which continued for millions of years, caused the continent to lose its former flora and fauna, and its surface became covered with vast ice and snow expanses. These changes continue to influence the Earth's climate system to this day and remain a subject of study for scientists exploring the consequences of global warming. It is astonishing, But tectonic processes and ocean currents played a decisive role in the climate change of Antarctica. Approximately 50 million years ago, during the Eocene epoch, Antarctica separated from Australia and South America, marking a turning point in its climate history. This separation contributed to the formation of the circumpolar current, which encircled the continent and created what is known as the cold barrier, isolating it from the warm equatorial waters. The temperature of the water in this current does not exceed a few degrees, and it was this current that became the main factor in the radical change of the region's climate. The circumpolar current not only cooled Antarctica itself, but also affected the global climate system. As a result of this current, the exchange of heat between the oceans and the atmosphere significantly changed, leading to changes in weather conditions in other parts of the world. For example, as a result of this, the formation of glaciers began to increase, reaching their maximum sizes during the Pleistocene. The ice sheets of Antarctica, which now cover almost 90% of the continent's surface, began to form at this time. Their area reaches around 14 million square kilometers, making it the largest reservoir of fresh water on the planet. In addition, changes in ocean circulation affected global meteorological conditions, including the formation of cyclones and anticyclones, which shape the climate conditions in distant regions such as Europe and North America. Scientists like Dr. James Hansen note that tectonic changes and the associated ocean currents served as catalysts for long-term climate changes that continue to manifest today. As a result of these changes, the ice sheets of Antarctica are now in such a state that any temperature changes could lead to their melting, which in turn would affect the level of the world's oceans. In recent decades, scientists have observed that the melting of glaciers in Antarctica is accelerating, which raises serious concerns about the future of our climate. In particular, in the 20th century, the sea level rose by 25 centimeters, and forecasts indicate a possible further increase of 1 centimeter per year meter by the end of the century if current trends continue. Long ago, when the world was filled with mysteries and unexplored lands, the first explorers bravely embarked on perilous voyages to uncover the secrets of the Southern Ocean. In 1773, English navigator James Cook, renowned for his triumphant expeditions, crossed the southern polar circle, unaware that behind the icy waters lay a vast continent. His ship, the Resolution, sliced through the cold waves, while the creaking of the ship's rigging under the icy wind created a sinister symphony. The sailors, wrapped in warm clothing, felt the icy wind burn their faces, leaving red marks on their cheeks. Cook did not discover the continent, but his voyages opened new horizons and laid the groundwork for future discoveries. Only a few decades later, in 1820, Russian navigators Fadi Bellingshausen and Mikhail Lazarev, aboard the sloops Vostok and Mirny, reached the shores of Antarctica. Their expedition was the first to see this mysterious continent, shrouded in an ice cover. The sun's rays reflected off the icebergs, creating blinding flashes, while the air was filled with the scent of salt and freshness. As the ships approached the shore, the sailors felt their hearts beat faster with anticipation of meeting the unknown. These were not just discoveries, they were steps in history that forever changed humanity's understanding of the planet. Bellingshausen and Lazarev documented their observations and opened new horizons that inspired subsequent generations of explorers. Their reports describe not only the majestic ice shelves, but also the complex ecosystems that thrived in the harsh conditions. The ships that sailed around Antarctica were surrounded by the sounds of cracking ice as massive icebergs broke off from glaciers and crashed into the sea with a roar. These moments of discovery were significant for science and geography, paving the way for further expeditions and research projects that continue to this day. Fadi Bellingshausen was the first to describe Antarctic landscapes, and his records on climatic conditions and ice formations continue to serve as the basis for climate research. The 18th and 19th centuries were an era of active exploration of Antarctica, which, despite its remoteness, captivated researchers with its mysteries and beauty. The time when brave explorers ventured into unknown lands knowing that they would face not only glory but also harsh trials became a true era of Antarctic exploration. At the beginning of the 20th century, three outstanding figures, Ernest Shackleton, Robert Scott, and Roald Amundsen, entered a battle for supremacy in the conquest of the South Pole. Shackleton, a British mariner, is known for leading his expedition in 1915 on the ship Endurance. During his journey, he encountered a catastrophe. The ice that was meant to be their ally became their enemy. The ship was destroyed in 1916 and the crew found themselves trapped in a vast white ocean. Their survival became a true feat. Shackleton and his 27 companions crossed ice fields, enduring temperatures as low as -50 degrees Celsius, and battled constant hunger. Blinding snow and howling winds seemed like wild beasts, but their spirit did not break. Meanwhile, Scott and his team, reaching the pole in 1912, discovered that Amundsen had beaten them by 34 days. Facing unbearable conditions, Scott and his team perished, leaving behind a tragic story of courage and perseverance. Amundsen, who arrived at the pole first, used dog sleds and well-planned supplies, which allowed him to return successfully, but his triumph was overshadowed by the loss of his rivals. These expeditions demonstrated not only physical strength, but also psychological resilience of people who ventured to the edge of the world to satisfy their thirst for knowledge and explore uncharted lands. Each of them left a mark in history, and their feats continue to inspire those who seek adventure. For instance, Shackleton became a symbol of human determination. His crew survived thanks to incredible will to live and leadership in the harshest conditions. In 1919, he managed to save all his people after 2 years on the ice, which was a true miracle. These stories show how far people are willing to go for science and themselves when it comes to fighting nature. Scientific expeditions to Antarctica today represent an extraordinary blend of human determination and advanced technologies. Scientists are studying subglacial lakes, which lie beneath multiple kilometers of ice, and these studies are opening new horizons in understanding Earth's climate and ecosystems. In 2017, an international team of scientists from Britain and Russia, using ice drills, successfully bored through ice over 3 kilometers thick and extracted water samples from Lake Vostok, one of the world's largest subglacial lakes. These drilling rigs are complex mechanisms that emit a low, droning sound as they penetrate the ice, and their operations are controlled by specialized computers located on the surface. Scientists monitor the process in real time, receiving data on temperature and pressure, which allows them to accurately assess the conditions under which these waters have existed for millions of years. Advanced technologies aid not only in drilling but also in the study of the lakes themselves. For instance, submersible robots like the Remotely Operated Vehicle, ROV, can perform complex tasks, including sample collection and video recording. These devices typically have bright bodies and are equipped with cameras capable of transmitting images in real time. They produce characteristic sounds during operation when their motors engage and the propellers start rotating. In 2018, a team of scientists from the University of Bristol used such robots to study the subglacial Lake Ellsworth, obtaining unique data on the microbial life that exists in complete darkness and under high pressure. Comparing these advanced technologies with the harsh conditions of Antarctica is awe-inspiring. While blizzards rage on the surface, scientists conduct their work beneath the ice using sophisticated systems developed over many years of research. The goal of such expeditions is not just to discover new knowledge, but also to understand how climate change affects our planet, as such research can reveal how the climate will change in the future. With these modern technologies, scientists hope to answer questions that have troubled humanity since ancient times and perhaps uncover secrets that the ice has held for millennia. As a result, Subglacial lakes become not only objects of study but also a kind of temporal capsule preserving the atmosphere of ancient Earth. Many people are unaware that subglacial landscapes can reveal a wealth of information about what happened on Earth millions of years ago. Scientists use advanced methods such as radar and seismic studies to examine hidden subglacial structures without the need for excavation. Radar systems send radio waves through the ice which reflect back when they reach the boundary between the ice and the subglacial surface. Scientists analyze these reflections to create radargrams, images that depict the profile of the subglacial landscape. For example, in the year 2000, a group of Swedish researchers conducted studies in the Antarctic region using radars to investigate subglacial lakes and discovered that some of them are over 1,000 meters deep. These radargrams are like true mirrors, showing not only the thickness of the ice but also the shapes of subglacial rivers and lakes that were previously hidden from view. Seismic methods are another powerful tool for studying subglacial landscapes. Researchers create artificial sound waves that penetrate the ice and reflect off various subglacial layers, creating three-dimensional images. For instance, in 2003, a group of scientists from the University of California conducted seismic studies in Greenland, which allowed them to discover subglacial rivers longer than several hundred kilometers. Such technologies not only help understand the structure of the subglacial relief, but also allow predicting how climate change will affect sea levels based on data on how quickly the ice is melting. The results of these studies are critically important for understanding global climate changes and their consequences for humanity. With methods like radar and seismics, scientists obtain data that can change our understanding of the past of our planet. It is important to note that without these technologies, many aspects of subglacial geography would remain unexplored. Subglacial landscapes exert a remarkable influence on the dynamics of glaciers and global climate. For instance, a study conducted in 2017 by a group of scientists led by Dr. Eric R. Rigneau of the University of Wisconsin-Madison showed that the shape of subglacial topography determines the speed and direction of glacier movement. Valleys guide the flow of ice, while mountains create natural obstacles, slowing its movement. These factors are critically important for understanding how glaciers respond to climate change. Subglacial lakes, such as Lake Vostok in Antarctica, create a unique environment where meltwater acts as a lubricant, accelerating the movement of ice on the surface. In 2008, researchers from NASA found that a subglacial lake that fills and empties can significantly increase the speed of glacier movement, sometimes by several meters per day. This lubricant allows ice to slide more easily over the base, leading to rapid changes in glacier systems. A study conducted by Dr. Susan K. Carter in 2009 confirmed that such subglacial lakes can act as important regulators of glacier dynamics, and their movement can significantly alter sea level. The connection between the invisible subglacial world and visible surface processes is evident. When glaciers start moving faster, this can lead to more intense melting and, consequently, to a rise in global sea level. Understanding these connections is critically important for predicting future changes in the ice sheet and broader climate impacts. For example, according to the Intergovernmental Panel on Climate Change, global sea levels could rise by 1 meter by the end of the century due to accelerated melting of Antarctic glaciers. Therefore, studying subglacial landscapes not only deepens our understanding of glaciers, but also helps predict how our future may be affected by climate change. Imagine a majestic ice river where ice flows instead of water. In Antarctica, there are colossal glacier streams that slowly move from the continent's center to the coast. These glaciers, like ice giants, compress and displace everything in their path, with their speed sometimes reaching several meters per day. For instance, the Taylor Glacier, one of the fastest moving in the world, moves at a speed of about 10 meters per day. Cracks form on its surface, reaching tens of meters in width and length. Ice shelves, like the Larsen ice shelf, float on the ocean surface, holding billions of tons of fresh water. These ice shelves act as barriers, slowing the flow of ice from the continent into the ocean. However, when ice shelves become too thin or unstable, they calve, creating icebergs the size of small countries. For example, in 2006, an iceberg the size of 9,000 square kilometers, roughly a third of Cyprus's area, broke off from the Larsen ice shelf. The sounds accompanying the movement of ice range from quiet cracking to thunderous roaring when icebergs break off and submerge in the ocean. These sounds create an atmosphere of power and grandeur that can be felt even at a distance. Standing on the surface of an active glacier, one can feel the vibration underfoot as the ice shifts and cracks. This process never stops and is crucial for understanding the ecosystem of the region and the global sea level. Studies show that the rapid melting of ice shelves could raise sea levels by several meters over the next century, affecting millions of people worldwide. In 2000, NASA scientists found that the rate of ice loss in Antarctica had tripled compared to the 1990s. These data confirm that the dynamics of ice in Antarctica represent one of the most pressing challenges of our time, as it affects not only sea levels but also global climate conditions. Geothermal heat hidden beneath the icy crust of Antarctica plays a crucial role in the movement of glaciers. Heat from the Earth's interior rises and warms the lower layers of the ice sheet, sometimes causing melting at the base. Volcanic activity on the continent, particularly in the region of volcanoes such as Mount Erebus, creates hot springs that heat the ice, and this phenomenon occurs at significant depths where temperatures can reach 30 degrees Celsius. Volcanic geysers and hot springs located under the ice cover create not only geothermal zones but also influence the structure and dynamics of glaciers. For instance, in 2005, a group of researchers from the University of Washington discovered that beneath the Taylor Glacier there are extensive subglacial lakes formed due to melting caused by geothermal heat. These lakes, located at a depth of about 2 kilometers, act as lubricants, allowing glaciers to slide more easily over the underlying surface. The contrast between the icy cold on the surface and the heat hidden deep within creates a unique dynamics that affects the speed of glacier movement. Glaciers such as the Lambert Glacier can move at speeds of up to 100 meters per year, making them some of the fastest in the world. This movement is explained not only by the force of gravity but also by the fact that water formed by melting at the base of the glacier reduces friction between the glacier and the underlying rock. Studies have shown that such subglacial water can form layers where pressure exceeds 1 atmospheric, further aiding the movement of ice. In 2006, geophysicists studying these processes noted that beneath the Williams ice stream there is an extensive network of underground waterways, further complicating the understanding of glacier dynamics. These facts underscore that geothermal heat and pressure play a significant role in changes to the ice cover, ultimately affecting sea levels and climatic conditions. It's hard to imagine, but in the cold depths of Antarctic waters, there exists a remarkable world teeming with unique creatures that have adapted to extreme conditions. In these dark and icy expanses where water temperatures can drop to -12 degrees Celsius, giant spiders with diameters up to 30 centimeters and long swaying legs inhabit the depths. These spiders rely on their powerful legs to move across the ocean floor, where they find their food, small crustaceans and other invertebrates. The waters around Antarctica are also home to special fish like the antifreeze fish, which has developed a unique protein in its blood that prevents it from freezing. This mechanism allows them to survive in the coldest waters on the planet. In 2005, scientists from the Australian Institute of Marine Science discovered that these fish can live at depths of up to 3,000 meters, where pressure exceeds 300 atmospheres. Their transparent bodies and distinctive features, such as large, glowing eyes, make them truly enigmatic inhabitants of the deep sea. A variety of invertebrates, including starfish and sponges, also form part of this ecosystem. Some, like sponges, can reach diameters of up to 1 meter and have an extraordinary ability to regenerate, allowing them to survive even in conditions of intense competition for resources. Interestingly, these organisms can filter vast amounts of water, cleaning it of particles and ensuring the purity of their environment. The darkness of the Antarctic depths creates a unique atmosphere where the light from bioluminescent organisms, such as certain types of jellyfish, penetrates the opaque waters, creating an effect of a starry sky on the ocean floor. These jellyfish use light to attract prey and repel predators. In response to threats, many organisms, such as sea urchins, can curl their spiky tentacles, exposing their sharp spines for defense. Scientific research conducted under the ANDEEP program since 2003 has shown that these depths are home to numerous previously unknown species. Scientists have discovered that the ecosystems of these waters depend on food that comes from the surface layers of the ocean, where photosynthetic organisms create the necessary nutrients. When they die, their remains sink to the bottom, providing food for the entire unique world. Climate change poses a threat to this fragile ecosystem. Rising water temperatures alter the migration and breeding habits of these creatures, which could lead to a decrease in their populations. As a result, these unique organisms, living in conditions seemingly incompatible with life, may face the risk of extinction. Scientific research continues to better understand how to preserve this remarkable world and its inhabitants. In 2017, scientists from the University of California documented a 30% decline in the population of some fish species over a decade. Bioluminescence in Antarctica is a remarkable phenomenon that enables the survival of deep-sea organisms in extreme conditions. Some fish species, such as the Antarctic squidfish, can produce their own light thanks to specialized organs containing luciferin, a chemical compound that, when reacting with oxygen, causes them to glow. This glow ranges from blue to green and even red, depending on the species and environmental conditions. For instance, deep-sea fish like the lanternfish use this light to attract prey, creating the illusion of larger organisms, which allows them to hunt small fish and shrimp. Meanwhile, some organisms use bioluminescence as a defensive mechanism. Bright flashes of light can deter predators, confusing them and giving the organism a chance to escape. This phenomenon is not limited to fish. Many invertebrates, such as Antarctic jellyfish and shrimp, also possess the ability to bioluminesce. They use light to find partners in the absence of light, which is critically important for their reproduction. The transparency of their bodies is another unique adaptation that helps them avoid predators. For example, the transparent bodies of Antarctic jellyfish allow them to blend in with their surroundings, making them virtually invisible to potential enemies. Unique survival strategies in these conditions also include the ability of some species to withstand temperatures close to zero, which, combined with bioluminescence, creates an extraordinary underwater landscape. These organisms, capable of surviving in such conditions, demonstrate exceptional adaptations that allow them not only to survive, but also to thrive in the most inaccessible corners of our planet. Bioluminescent organisms in Antarctica not only amaze, but also highlight the fragility of ecosystems that depend on this natural magic. On February 18, 2016, scientists from the Polar Research Institute discovered a new species of glowing jellyfish that emits bright green light, marking a significant discovery in the study of deep-sea ecosystems. Remarkably, life continues to amaze us even in the most uncompromising conditions, and Antarctica is no exception. In dry valleys where precipitation is almost non-existent, microorganisms thrive at temperatures as low as -20 degrees Celsius. These organisms, such as bacteria of the Planococcus genus and microalgae, find refuge in saline lakes where salt concentration can exceed 60 grams per liter, creating conditions unsuitable for most forms of life. Interestingly, these microorganisms can remain in a state of dormancy for decades, requiring virtually no energy for their survival, allowing them to wait for more favorable conditions for growth and reproduction. For instance, in Lake Vostok, which lies beneath a thick layer of ice, scientists discovered live bacterial colonies that use methane and other organic compounds as a source of energy. Studying such organisms provides insights into how life can exist in extreme conditions on other planets, such as Mars or Jupiter's moons, where conditions may be equally harsh. Researchers at the University of Oslo in 2020 conducted a study analyzing ice samples from Antarctica and found that many of these microorganisms possess the ability to photosynthesize even in conditions where sunlight is almost absent. They use any available light sources to create energy, making them true masters of adaptation. Scientific research demonstrates that the diversity of life on Earth knows no bounds, and even in such extreme conditions as Antarctica, life finds ways to exist. For example, bacteria living in ice cracks can switch between active and dormant states depending on the environmental conditions. This discovery confirms that microbial life on Earth is not only resilient, but also incredibly inventive. Consequently, studying these forms of life not only fills us with wonder, but also opens new horizons for astrobiology and understanding the potential forms of life in the cosmos. Furthermore, in 2019, researchers from Harvard University discovered that some of these organisms can accumulate and use carbon dioxide, opening possibilities for their application in biotechnology and eco-friendly technologies. In Antarctica, life does not just exist, it demonstrates an incredible diversity and adaptability, underscoring how all-encompassing and inventive life can be on our planet. Imagine ice-covered lakes where human foot has not stepped for millions of years, yet life continued to develop in complete isolation. One of the most famous such bodies of water is Lake Vostok, located beneath the ice sheet of Antarctica. It is situated at a depth of more than 3,000 meters and has an area comparable to that of the United Kingdom. The water in Lake Vostok, according to scientists' estimates, has been isolated from the outside world for about 24 million years, which allows for the assumption of the existence of unique ecosystems. In 2012, Russian scientists successfully drilled through the ice and obtained water samples without contamination, which is a significant achievement given the challenging conditions. They used special technologies, such as hermetically sealed samplers, to avoid contact with air and preserve microbial life. As a result, microorganisms were discovered that are believed to have evolved independently of all life on the surface. These organisms differ from known species, opening new horizons in the study of life on Earth and potentially beyond. Lake Whillans, located in Antarctica, also attracts the attention of researchers. It is completely isolated and has a unique chemical composition containing high levels of salts and minerals. In 2018, a team of scientists from the University of California took water samples and discovered that they contained microorganisms capable of photosynthesis despite the absence of sunlight. This ability is surprising as it suggests that life can adapt to the most extreme conditions. No less interesting is Lake Ellsworth, which is located under the ice cap of Antarctica. In 2006, as a result of drilling, scientists gained access to its waters and discovered that they contained high concentrations of methane and other hydrocarbons. This discovery challenges traditional notions of how life could have developed in such isolated conditions. These subglacial lakes represent not only exotic worlds but also important objects for scientific research. Scientists from different countries, including Russia, the United States, and the United Kingdom, are actively studying them, aiming to understand how life can exist in conditions that seem absolutely hostile. The water in these lakes is usually very clean and has a unique isotopic composition, making them ideal for studying climate and ecosystem changes in the past. Research shows that the isolation of these bodies of water has led to the formation of biological communities that may have properties different from anything we know. For example, microorganisms found in Lake Vostok may have unique genetic characteristics that allowed them to adapt to conditions where pressure exceeds 200 atmospheres. These facts highlight that subglacial lakes can be not only homes for unique forms of life, but also real laboratories where the process of evolution can be studied in real time. One of the most intriguing hypotheses is that these water bodies could have evolved species that are unknown to science. Given that these ecosystems have existed in complete isolation for more than 20 million years, they may contain organisms that are fundamentally different from anything known on the surface of the Earth. This opens not only scientific but also philosophical questions about the nature of life and the extent to which the world is diverse, which is yet to be discovered. In the end, the subglacial lakes of Antarctica become key objects for understanding not only our planet, but also the ability of life to adapt to the most extreme conditions. Scientific research continues, and each water sample opens new horizons for understanding the evolution of living organisms. For example, the water of Lake Vostok contains around 30,000 years of history, allowing researchers to look into the past of the Earth and understand how the climate and ecosystems have changed over millions of years. Subglacial lakes in Antarctica are not only unique ecosystems, but also significant objects for astrobiology, as their conditions may provide insights into the potential for life on other planets and their moons. Moons of Jupiter, such as Europa and Ganymede, and Saturn's moon Enceladus, are characterized by the presence of subglacial oceans, which are believed to contain liquid water beneath thick layers of ice. These conditions are similar to those found in Antarctic lakes, where temperatures can drop to -30 degrees Celsius, and the pressure of the ice creates high barrier conditions for life. Scientists like Dr. Christopher Bennett from the National Oceanic and Atmospheric Administration in the United States are developing new technologies to study these isolated bodies of water, including autonomous submersibles and robots capable of collecting water samples and analyzing microbial communities. These technologies not only help in understanding life in Antarctica, but can also be adapted for future missions to other celestial bodies, such as NASA's planned Europa Clipper mission, which will explore Europa for signs of life. Comparison with conditions on other planets becomes increasingly justified. If life can exist in these isolated subglacial lakes, it is likely that it could also exist in similar conditions on Europa or Enceladus. Research conducted in Antarctica also helps to understand how organisms can adapt to extreme conditions, such as low temperatures and lack of light, which could be critically important in the search for extraterrestrial life. For example, in subglacial lakes, microorganisms have been found that can survive in conditions where oxygen levels are extremely low and energy sources are limited. These organisms, such as bacteria from the Cycrobacter genus, can serve as a model for understanding how life might function on other planets with similar conditions. All this work not only expands our understanding of life on Earth, but also prepares us for what we might find on other planets. Antarctica, in this context, becomes a kind of laboratory where scientists can test hypotheses and technologies before venturing into space. Subglacial lakes offer a unique opportunity to study ecosystems that have been isolated for thousands of years, allowing researchers to look into the past of our planet and perhaps into the future of extraterrestrial life. Scientists have discovered that Lake Vostok contains approximately 30,000 years of isolated water, making it a key object for study. These research efforts not only highlight the uniqueness of Antarctic ecosystems, but also create a basis for the search for life on other planets, where conditions may be similar to those we observe in Antarctica. Ice cores extracted from Antarctic ice represent true archives of ancient climate, where each layer of ice is a page in Earth's history. These cylindrical samples, with a diameter of about 10 centimeters and a length of several kilometers, store information about temperature, atmospheric composition, and volcanic activity over thousands of years. Research shows that each year in polar regions, a new layer of ice accumulates, which can be compared to the rings in a tree trunk. With the help of specialized drills, such as those developed in the early 2000s, scientists can extract these cores allowing them to see distinct annual layers that reflect changes in climate and atmospheric condition. For example, in one of the deepest cores extracted in 2015 at the Vostok station, the ice is approximately 800,000 years old, making it one of the oldest climate archives on the planet. Analysis of isotopes of oxygen and carbon in these samples allows scientists to reconstruct the climatic conditions that existed on Earth during different historical periods. Sharp temperature changes corresponding to glacial periods and interglacial intervals have been discovered, demonstrating the link between atmospheric carbon dioxide concentrations and global temperatures. Volcanic activity also leaves its mark in these cores. Particles of ash that enter the ice allow scientists to determine the date and scale of eruptions. Each extracted sample is not just ice, but a repository of information that helps us understand how our planet has changed and how it may change in the future. Scientists from various countries, including the Alfred Wegener Institute in Germany and the Center for Climate and Polar Research in the USA, are actively working with these samples, analyzing data to predict the consequences of climate change. These studies help not only to understand the past, but also to prepare for possible changes that may occur in the future. Each centimeter of this ice is a testament to how, in times when there were no people on Earth, the climate changed, and how these changes affected life on the planet. Each ice core is not just a frozen chunk of nature, but an entire book written by the climate of our planet. To extract them, scientists use specialized drilling rigs capable of penetrating ice layers up to 3 kilometers deep. These rigs are typically complex mechanisms operating on the principle of diamond drilling, allowing them to obtain cylindrical ice samples with a diameter of about 10 centimeters. After extraction, the cores are carefully packed in special containers to protect them from external influences, preventing melting and contamination. They are then transported to research laboratories where strict temperature control is maintained. In these laboratories, the ice samples are placed in cold chambers where the temperature reaches -30 degrees Celsius and below to preserve their original state. The study of ice cores involves a wide range of analysis methods. One of the simplest but most effective is the visual examination of annual layers, which allows determining climate changes over hundreds and thousands of years. Each line and color is evidence of the conditions that existed during a particular period. More complex methods include mass spectrometry, which allows studying the composition of air bubbles trapped in the ice, and isotopic analysis, which helps determine the temperature and composition of the atmosphere in the past. For example, oxygen isotope analysis can show temperature changes, while carbon isotope analysis can indicate changes in the level of carbon dioxide. This approach allows reconstructing the climate history spanning tens of thousands of years and understanding how the planet reacted to past changes. Scientists working with ice cores typically need not only technical skills but also patience, as the analysis of each sample can take months, if not years. Each step of this process requires a high degree of accuracy, as even a minor error can distort the results. For instance, in 2006, a group of researchers from the Alfred Wegener Institute in Germany analyzed samples from Antarctica and found that the level of carbon dioxide in the atmosphere was significantly higher than previously thought, which changed our understanding of climate fluctuations. With the help of ice cores, scientists can not only reconstruct the past, but also predict how the climate may change in the future, making this work particularly relevant in light of contemporary global changes. It is astonishing that data from ice cores allows us to peer into the atmosphere that existed tens of thousands of years ago. Scientists can reconstruct the temperatures of past epochs by analyzing the ratio of oxygen isotopes in water molecules that form ice. For instance, in samples collected in Greenland, the ratio of oxygen 16 to oxygen 18 helps determine how cold or warm the climate was during a particular period. The more oxygen 16 in the samples, the colder the climate, as lighter molecules evaporate and condense more easily in cold periods. Ice cores collected in Antarctica also contain air bubbles that act as true time capsules. By analyzing their composition, scientists can determine the concentration of carbon dioxide, methane, and other greenhouse gases in the ancient atmosphere. For example, in samples from glaciers dating back to the last ice ages, the concentration of carbon dioxide was around 250 parts per million, significantly lower than today's levels, which exceed 400 parts per million. These data reveal the cyclical changes in Earth's climate, alternating between ice ages and interglacial periods. Every 100,000 years, there were significant temperature fluctuations linked to changes in Earth's orbit and solar activity. Using radiocarbon dating methods and studying isotopic ratios, scientists can accurately determine when these changes occurred, such as the end of the last ice age, which happened approximately 10,000 years ago. These scientific methods enable us to effectively travel through time, reconstructing the climate history of the planet. However, the current rapid increase in greenhouse gas concentrations is occurring at a pace far greater than any natural changes observed in the past. For example, over the last 100 years, the level of carbon dioxide has increased by more than 30%, the fastest rate in the last 800,000 years. Volcanic activity in Antarctica plays a crucial role in shaping the continent's climate and, ultimately, the world's climate. For instance, Mount Erebus, located on Ross Island, is considered one of the world's most active volcanoes. Its constant fumarolic activity creates columns of steam and sulfur gas rising above the snow-capped peaks, while the reddish glow of molten lava contrasts with the whiteness of the surrounding ice. Mount Melbourne, located on Scott Island, also exhibits activity, with eruptions occurring approximately every 20 years, releasing significant amounts of ash and gases into the atmosphere. Mount Deception, situated on Deception Island, is known for its explosive eruptions that can reach heights of up to 1,000 meters, creating ash clouds that spread over large distances. These eruptions are not merely spectacles, but are also significant factors influencing the regional climate. Volcanic activity contributes to the formation of melt zones at the bases of glaciers, disrupting the stability of the ice cover. This occurs because the heat released during eruptions warms the ice and causes it to melt. As a result, sea levels can rise, posing a threat to coastal regions. Furthermore, the release of particles such as sulfur and ash from volcanic eruptions can reflect sunlight, causing temporary global cooling. Volcanic dust can remain in the atmosphere for several months, affecting the climate not only in Antarctica but also on other continents. An example of this is the eruption of Krakatoa in 1883, which caused global cooling and lowered the average temperature by several degrees. Volcanic activity in Antarctica not only creates unique natural phenomena such as fumaroles and lava flows, but also significantly impacts the regional climate, underscoring the importance of studying these processes for understanding global climate change. For example, Mount Erebus has an active crater that continuously releases gas, creating a unique ecosystem around it where rare animal and plant species thrive. The ice cover of Antarctica is not just a massive ice sheet, but a true chronicle of climatic changes reflecting the Milankovitch cycles. These cycles, named after the Serbian scientist Milutin Milankovic, are periodic changes in the Earth's orbit and axis of rotation, occurring at intervals of 20 to 150,000 years. They influence the amount of solar radiation received by the planet, which in turn triggers global climate change mechanisms. For example, when the Earth's axis tilts, it alters the distribution of sunlight, which can lead to warming or cooling. Ice cores extracted from the depths of Antarctic ice show these cycles as clearly defined layers, where each layer corresponds to a specific period of time. Analysis of these cores allows scientists to observe periodic changes in temperature and concentrations of greenhouse gases, such as carbon dioxide and methane. For instance, recent studies conducted by scientists at the Institute of Polar Research have shown that the level of carbon dioxide in the atmosphere fluctuated significantly between 100 and 115,000 years ago. directly correlating with temperature changes recorded in ice cores. These data confirm that climatic changes are not random, but follow specific astronomical cycles. Each time the Earth passes through certain phases of its orbital cycle, it triggers a chain reaction in the atmosphere and climate systems, which can be compared to a massive mechanical device where a slight change in one part can lead to significant consequences in others. Thus, the ice cover becomes not just a natural phenomenon, but a universal archive that links the movements of the Earth in space with the climate on its surface. Research shows that over the last millions of years, Earth has experienced both long ice ages and warm periods when the temperature rose by tens of degrees. For example, during the Eemian interglacial period, which lasted around 150,000 years ago, the average temperature on the planet was 3 to 4 degrees higher than it is now. This time was marked by significant melting of ice and a rise in sea levels, which is confirmed by geological data from coastal deposits. The true significance of ice cores lies in their ability to allow us to look into the past and understand how our planet responded to changes in solar radiation. Scientists such as Dr. James Bennett from the University of Cambridge emphasized that studying these processes is necessary for predicting future climate changes, as we are on the threshold of a new cycle that could have a significant impact on life on Earth. Thus, in recent decades, there has been a sharp increase in the concentration of greenhouse gases, which has caused concern among climate scientists about how this will affect the overall climate system. Projections show that if current trends continue, the temperature on the planet could increase by 2 to 3 degrees by the end of the 21st century. These figures cause serious concern, as even small changes in temperature can lead to catastrophic consequences such as massive ice melt, sea level rise, and changes in ecosystems. Comparing data from ice cores with modern indicators, scientists can create models that better explain how human activity affects the climate. For example, the increased use of fossil fuels and deforestation has led to the level of carbon dioxide in the atmosphere reaching record levels, exceeding 800 parts per million. This level has not been observed for thousands of years, and its consequences may be unpredictable. It is important to understand that the ice cover of Antarctica not only reflects climatic changes, but also serves as a warning that we must consider in our interaction with nature. Did you know that there is a unique place in Antarctica where it never snows? This is the dry valleys of McMurdo, where nature has created a truly alien landscape. These ice-free valleys, located at an altitude of about 1,000 meters, are stony expanses with bright red and brown rocks, reminiscent of Martian landscapes. The surface of the valleys is strewn with sharp rocks and rock formations that are subjected to intense erosion due to strong winds. In these places, you can see salt lakes, such as Lake Winter, whose surface sparkles with salt crystals, and the shores are covered with white, crystalline formations that contrast with the surrounding reddish-brown rocks. These lakes formed as a result of the evaporation of water when ancient rivers, which once flowed through these valleys, left behind minerals and salts. It is interesting that in the dry valleys of McMurdo, there is almost no vegetation, with only rare patches of lichen struggling to survive in the lifeless landscape. These lichens, surprisingly, are able to exist precisely because of the minimal amount of moisture they receive from the atmosphere. The reason these valleys remain ice-free is due to katabatic winds that blow snow off the surface and the low humidity of the air, which prevents even the most severe winter months from retaining snow on these lands. These winds can reach speeds of over 100 kilometers per hour, creating conditions where snow simply cannot accumulate. The dry valleys of McMurdo cover an area of about 30,000 square kilometers and are one of the driest places on Earth, where annual precipitation does not exceed 200 millimeters. Research shows that the climate of these valleys has not changed over millions of years, and they serve as evidence of how a planet might look under extreme climate conditions. In this context, it is worth noting that scientists such as Dr. John Carey from the University of Washington study these regions to understand how life can adapt to such harsh conditions, making these valleys a valuable object for the study of climate change and ecosystems. Beneath the icy cover of Antarctica lie astonishing geological formations that until recently remained hidden under their icy cloak. The Gumburtsev Mountains, a massive mountain range stretching over more than 300 kilometers, is completely concealed beneath kilometers of ice. These mountains reach heights of up to 2,000 meters and are one of the most mysterious places on the planet. Their geological features include complex fold structures and diverse rock types, making them a subject of interest for geologists worldwide. Scientists like Dr. Elizabeth Taylor from the Polar Research Institute used radar and seismic studies to discover these mountain ranges at the center of the continent. During their research, they were surprised to find such a large mountain system, about which they had no previous knowledge. The discovery of the Gumburtsev Mountains was akin to finding a new continent, as they represent a whole world hidden under a thick layer of ice. However, the origin of these mountains is still a subject of debate among geologists. Some argue that these formations were created as a result of the collision of ancient continental plates, while others link them to volcanic activity that may have occurred millions of years ago. As a result of these debates, the scientific community continues to study the Gumburtsev Mountains to unravel the mysteries they hold. These studies not only deepen our understanding of the geological history of Earth, but also open new perspectives in the study of climate change, as the composition and structure of the mountains can provide important clues about our planet's past. The complex processes that shape these mountains are still awaiting explanation, and each new discovery brings us closer to understanding their true nature. Above their peaks rise not only icy clouds, but also questions to which scientists continue to seek answers. Currently, it is known that the Gumburtsev Mountains are part of a larger mountain system, including other subglacial ranges that also remain unexplored. Under the icy shield of Antarctica lies a true subglacial hydrological system, consisting of rivers, streams and lakes that form due to meltwater. This water is generated from the base of glaciers due to the pressure of the ice mass and geothermal heat, creating complex water flows. Research has shown that beneath millions of tons of ice lie vast subglacial lakes, such as Lake Vostok, covering an area of about 11,000 square kilometers and with a depth of more than 1 kilometer. These lakes are interconnected by a network of rivers and streams that can flow at depths of up to 3 kilometers beneath the ice surface. Meltwater, formed as a result of sunlight and Earth's heat, slowly moves from one lake to another, creating a dynamic hydrological environment. This water movement affects the movement of the ice itself, altering its speed and structure. For example, subglacial rivers can act as lubricants, allowing glaciers to move faster towards the sea. In 2018, scientists from the British Antarctic Survey used radar technologies to map subglacial lakes and rivers, revealing how these water flows change over time. They discovered that the subglacial system is much more dynamic than previously thought, with changes occurring over days or even hours. This hidden ecosystem, existing in complete darkness, is home to microorganisms that have adapted to extreme conditions. Research indicates that subglacial waters may contain unique forms of life that have evolved in isolation over millions of years. This mysterious world, hidden beneath kilometers of ice, opens new horizons for science, offering unique opportunities for studying Earth's climate and its changes. In recent years, scientists have also begun to investigate how climate change affects this subglacial hydrological system, which may have serious consequences for sea level and global climate. Important findings on how meltwater interacts with ice can help predict how quickly glaciers will respond to global warming. For instance, a study published in 2020 showed that underwater currents changing due to warming can accelerate the melting of tidewater glaciers. This information is becoming increasingly relevant as sea level continues to rise, threatening coastal regions worldwide. In Antarctica, there exist geothermal sources that are striking in their contrast with the surrounding environment, where ice and cold reign supreme. For example, on Deception Island, part of the South Shetland Islands, there are hot springs with water temperatures that can reach 90 degrees Celsius. These sources are located in the crater of a volcano, and their steam rises high above the surface, creating a mesmerizing sight. Vibrant colored mineral deposits forming around the sources contrast with the whiteness of the ice and snow, creating a unique palette of hues, from bright yellow to rich orange. Places like the hot springs on Deception Island are ecosystems where life, seemingly impossible, thrives. Water rich in minerals and high temperature supports the life of microorganisms such as thermophilic bacteria, which have adapted to extreme conditions. These microorganisms can survive in water with high acidity and temperature, making them of interest for study, especially in the context of searching for life on other planets. Under the ice of the Taylor Glacier, located on the western Antarctic Peninsula, there are also underwater hot springs that release minerals, creating unique ecosystems. The water temperature here can also reach 90 degrees Celsius, allowing various forms of life to flourish even in the harshest conditions. The comparison of the icy landscape and the hot springs creates a unique atmosphere. Steam rising from the hot water combines with the cold air to form ghostly clouds that captivate with their beauty. This contrast demonstrates how ecosystems can exist in the most unexpected conditions. The geothermal sources in Antarctica not only attract the attention of scientists, but also become objects of study for climate change, as their activity can indicate processes occurring under the ice. Antarctica is not just a lifeless, icy wasteland, but a continent where nature showcases all its contrasts and diversity. This region boasts unique landscapes, from vast ice plains to majestic mountain ranges. For instance, the Totten Glacier, stretching over more than 130 kilometers, is one of the largest and most active glaciers in East Antarctica. Its colossal ice masses rise to heights of up to 3 kilometers above sea level, creating dazzling white plains that sparkle like millions of diamonds scattered across the surface on sunny days. In stark contrast to these endless ice sheets, black volcanic peaks such as Mount Erebus rise up. This is the southernmost active volcano on the planet, with its crater constantly emitting smoke and temperatures reaching over 160 degrees Celsius, creating a unique landscape where ice and volcanic activity coexist in remarkable harmony. Dry valleys like the McMurdo Valley are striking with their reddish-brown rocks and almost complete lack of snow. These valleys are among the driest places on Earth, where it may not rain for millions of years. Here, light plays on the surface, creating unexpected hues and shadows that change with the time of day and the angle of the sun's rays. Morning light bathes the rocks in a soft golden hue, while evening shadows give them a more dramatic appearance. Viewing Antarctica from a bird's eye perspective reveals how ice shelves, such as the Ross Ice Shelf, form massive plates attached to the coast, with their edges plunging into the turbulent sea. These glacial formations not only impress with their scale, but are also crucial for studying climate change. Glaciers melting due to global warming can lead to sea level rise, posing a serious threat to coastal regions worldwide. Each season in Antarctica brings its own changes. In summer, temperatures can rise to plus 10 degrees Celsius, causing sea ice to retreat and opening new land areas for colonies of penguins, like the emperor penguins, to breed. In winter, temperatures can drop to minus 50 degrees Celsius, with winds reaching speeds of up to 130 kilometers per hour, creating conditions where only the hardiest organisms can survive. Antarctica is not a monotonous white landscape, but a complex and diverse continent where every change in light and time of day reveals new facets of its beauty. In this harsh yet wondrous place, nature demonstrates its power and fragility equally. The existence of unique ecosystems such as penguin colonies along the coast and hidden underwater worlds teeming with life confirms that even in the most extreme conditions, life finds a way to survive and adapt. Antarctica, with its majestic glaciers, volcanic mountains, and harsh valleys, remains one of the most mysterious and studied corners of our planet. The ice cover of Antarctica plays a key role in regulating global climate, acting as a giant air conditioner for the Earth. The snow-white surface of this continent reflects up to 90% of the sunlight that falls on it, preventing the heating of the surface and atmosphere. This effect is known as albedo, and it is critically important for maintaining a stable temperature on the planet. For example, according to scientists, if all the ice cover were to disappear, the Earth's temperature could rise by several degrees, leading to catastrophic consequences for the climate system. Existing models show that even small changes in albedo can trigger a chain reaction, leading to further melting of the ice. According to research conducted in 2020, the area of the ice cover in Antarctica has decreased by more than 1,000 square kilometers compared to previous decades. This reduction leads to a positive feedback loop. As the area of ice decreases, so does the amount of reflected light, which in turn leads to more heat absorption. NASA scientists have calculated that a 10% decrease in albedo can increase the average temperature on the planet by 1 degree Celsius. This means that Antarctica is not just a frozen continent, but an important element in the complex system of climate regulation. The ice shield that covers about 90% of Antarctica contains about 70% of the fresh water on the planet. When this ice melts and flows into the oceans, it further contributes to the rise in sea level. In 2013, scientists recorded a record melt of ice in West Antarctica, which led to a rise in sea level of more than 3 millimeters. Such changes can threaten coastal cities around the world, from New York to Tokyo, forcing governments to reassess strategies for managing water resources and adapting to climate change. Antarctica also influences ocean currents. The melting ice releases fresh water that affects the density and temperature of the oceans. This, in turn, can change the movements of currents such as the Gulf Stream, which play a critical role in the climate of Europe and North America. According to climatologists, changes in these currents can lead to abrupt climate changes in Europe, including colder winters and unusual weather conditions. Thus, the ice cover of Antarctica not only reflects solar radiation, but also influences climate systems around the world. Research shows that preserving this cover and its stability against temperature changes are vital for preventing global warming and preserving marine ecosystems. In 2000, researchers from the University of London found that at the current rate of temperature increase on the planet, a large part of the Antarctic ice could disappear by the end of the century, creating not only ecological but also social and economic problems for millions of people. Cryoconite holes are a remarkable testament to how life finds ways to survive even in the most extreme conditions. These small bodies of water form on the surface of glaciers when dark particles of dust, carried by the wind, absorb solar heat and melt the ice beneath them. At first glance, cryoconite holes appear as small, dark spots scattered across the silent, snow-white surface of glaciers. However, upon closer inspection, one can see miniature ecosystems teeming with life. These water bodies are home to various microorganisms such as algae, bacteria, and microscopic animals that create complex food chains. For instance, on Taylor Glacier in Antarctica, algae of the Chlamydomonas genus were found, which can survive temperatures below zero. These algae serve as the foundation for more complex ecosystems, where bacteria and microscopic animals like rotifers and crustaceans use the algae as a food source. Studies show that even in such harsh conditions as Antarctica, life not only exists but also develops, adapting to its environment. In 2006, researchers from the University of Wisconsin-Madison conducted a study of cryoconite holes on Mercer Glacier, revealing that these miniature ecosystems host complex interactions between different species that can serve as indicators of climate change. These holes are not just bodies of water, they are true biological laboratories where life in the constant cold and limited light finds ways to survive. Their existence demonstrates the remarkable adaptability of ecosystems and underscores the importance of studying these unique biotopes for understanding changes in climate and the planet's ecology. In the 21st century, cryoconite holes have become the subject of active research as scientists strive to understand how they might influence global climate processes. Each such hole can contain up to several liters of water and serve as a home for diverse forms of life, including unique bacterial strains that may have significance for biotechnology and medicine. In Antarctica, there are remarkable subglacial rivers and waterfalls that challenge our understanding of life in extreme conditions. One of the most famous phenomena is the blood falls in the dry valleys of McMurdo. Water flowing from the subglacial Lake West is rich in iron oxide, giving it a bright red color. This contrast between red streams and white ice framed by grey rocks creates a spectacle that appears as if the glacier is bleeding. Such scenes not only captivate the imagination, but also have significant scientific importance. The water in this waterfall contains ancient microorganisms that have evolved in isolation over millions of years. These organisms have survived in extreme cold and high salinity, making them unique subjects for study. Scientists studying the blood falls can better understand how life might exist on other planets, such as Mars, which also has subglacial bodies of water. Such research allows us to make inferences about potential ecosystems on other celestial bodies, as conditions on Mars may resemble those in Antarctica. Waterfalls and rivers like the blood falls play a crucial role in understanding not only Antarctic ecology, but also potential forms of life in other corners of the universe. For example, in 2009, scientists from the University of Wisconsin conducted a study that showed microorganisms found in such subglacial waters may have similar survival mechanisms to those found on other planets. This discovery underscores that Earth can serve as a kind of laboratory for studying extraterrestrial life. The blood falls and similar phenomena become key objects for further research, helping us not only to understand our planet, but also to expand the horizons of life search beyond its boundaries. Scientific research of these unique ecosystems continues, and each new experiment brings astonishing results. Imagine the colossal continental shelf glaciers of Antarctica stretching hundreds of kilometers from the continent's shore into the ocean. These ice platforms, some of which are comparable in size to France, exhibit extraordinary dimensions. Their thickness can reach several hundred meters, and the height of vertical cliffs can rival that of multi-story buildings. Dazzlingly white, these ice masses shimmer in the sun, creating breathtaking contrasts with the deep blue waters of the ocean. When icebergs break off from the shelves, the process is accompanied by sounds ranging from soft creaking to thunderous roars, reminiscent of distant thunder, imparting a sense of dynamism and power to this frozen realm. Shelf glaciers play a crucial role in stabilizing continental ice sheets, acting as a kind of cork that prevents their movement towards the ocean. For instance, the Larsen Glacier on the eastern coast of Antarctica has shown signs of instability over the past decades, causing serious concern among scientists. In 2001, a section of Larsen B broke off, creating an iceberg with an area of approximately 13,000 square kilometers. Such events underscore the vulnerability of these systems and their significance for global climate change. Studies indicate that shelf glaciers are losing mass each year, and according to scientists, the rate of their melting increased by 30% between 2009 and the previous decades. The loss of glaciers could lead to a rise in global sea levels by several meters, affecting millions of people living in coastal areas. Experts like Dr. Eric Rapp, who conduct research in climate science, argue that more attention should be paid to monitoring these ice giants. Satellite observations, for example, indicate that ice shelves like Phillips and Ron will continue to shrink if global temperatures continue to rise. 80% of Antarctica's ice cover is located on the continent, and shelf glaciers play a decisive role in holding this mass in place, making them the focus of close scrutiny for climatologists and ecologists. Antarctica is not just an icy continent, but also a treasure trove of cosmic mysteries. Meteorites found on its surface become precious treasures for scientists. These dark rocks of cosmic origin, contrasting with the white ice, stand out against the backdrop of the lifeless desert. The movement of glaciers plays a decisive role in concentrating meteorites in certain places, forming what are known as meteorite traps. In such places, scientists find meteorites of various sizes and shapes, from small stones to large specimens the size of a fist. Their surfaces are often melted, indicating the high temperatures they experienced upon entering Earth's atmosphere. Some of these meteorites have Martian or lunar origins. For example, in 2008, an Australian expedition discovered a meteorite belonging to the SNC, Shergotite, Naklite, Chasignite type, known as Martian meteorites. This discovery confirmed that Antarctica serves not only as a window into Earth's past, but also into the history of our solar system. Thanks to its dry and cold climate, meteorites here are preserved in an ideal state, free from erosion and contamination, making Antarctica a unique place for the study of extraterrestrial materials. Scientific research on these meteorites helps scientists understand how planets formed, what processes occurred in the early solar system, and even study possible conditions for life on other planets. For instance, the ALH 84001 meteorite found in Antarctica in 1984 became one of the most discussed objects because it contained structures that some scientists interpreted as evidence of ancient Martian microbes. Overall, each discovered meteorite opens new horizons for astronomers and geologists, allowing them to delve deeper into the history of our cosmos. In Antarctica, amidst the contemporary ice deserts, remarkable evidence of ancient vegetation that once covered this continent is hidden. Fossilized tree trunks found in the region resemble a time when southern beeches and conifers grew here, along with lush ferns. These trunks, preserved for millions of years, bear annual rings that allow scientists to accurately determine the age of the trees and the climatic conditions in which they grew. For instance, finds in the vicinity of Sandwich Bay indicate that these trees could reach heights of up to 30 meters, with diameters sometimes exceeding 1 meter. Fossilized leaves with clearly visible veins provide insight into the diversity of flora that existed at the time. In particular, species such as the metasequoia, which today inhabit only warm climates, have been identified. These discoveries not only confirm that Antarctica was once part of a warmer, wetter world, but also assist scientists in reconstructing the ancient climate, which could have been significantly milder than today. Pollen and spores of plants found in the fossilized remains offer the opportunity to study how the continent's ecosystem changed over time, adapting to climatic changes. Remarkably, such research shows that during the Mesozoic era, Antarctica was not just a desert, but a true paradise with diverse flora and fauna that thrived on these lands. Comparing these ancient forests with the modern ice plains, scientists realize how dramatically the planet's climate has changed over millions of years. Findings in Antarctica also help understand which plant species were dominant and how they interacted with their surroundings. Research shows that many of these ancient species, such as conifers, have gone extinct, but their descendants still exist in warmer corners of the Earth. Beneath the thick ice of Antarctica lie not only ice masses but also mountain ranges and deep valleys, forming a complex relief of this continent. The Transantarctic Mountains stretch for 3,500 kilometers across the continent, dividing eastern and western Antarctica. These mountains, with heights exceeding 4,000 meters, are true giants creating strong barriers to the movement of glaciers. Valleys formed by centuries of erosion and ice movement are deep canyons, some of which descend below sea level, with their bottoms reaching depths of up to 700 meters below sea level. These geographical features influence the flow of glaciers, directing them in certain directions and creating obstacles in their path. Glaciers sliding down the mountains encounter these barriers and change their direction, creating complex systems of cracks and faults. As a result of this interaction, the ice cover forms a multi-layered structure, each layer containing information about the climates of past epochs. If the ice were to melt, we would see Antarctica in a completely different light. Instead of a single massive continent, we would see an archipelago of islands separated by straits and fjords. In such a case, the mountains would be visible, and their outlines would resemble the breathless reefs washed by the sea. This is not just a theoretical concept. As a result of climate change and global warming, we are observing how some of these glaciers are already retreating, revealing previously hidden landscape areas. Research shows that such dynamics can lead to significant changes in sea level, which in turn will affect coastal ecosystems and populated areas around the world. Antarctica, as a crucial part of the global climate system, remains under the close scrutiny of scientists who continue to study its relief, climate, and the consequences of temperature changes. In Antarctica, there are hidden subglacial canyons that are so vast in size they defy imagination. Some of them are deeper than the Grand Canyon. For instance, the recently discovered canyon beneath the Denman ice shelf, which is the deepest point on Earth's surface, plunges 3,500 meters below sea level. This canyon was likely formed by ancient rivers that flowed across the continent before it became glaciated, and then was deepened by the movement of glaciers that slowly and inexorably advanced across its surface. Imagine these rivers, once teeming with life, leaving deep traces on the landscape that are now concealed beneath a multi-kilometer layer of ice. Research shows that these subglacial canyons are not just geological formations but are crucial components of the climate system. Scientists like Dr. Jonathan King from the University of Bristol are studying these canyons to understand how water circulates beneath the ice sheet and how this affects its stability. This information is critically important for predicting future sea level changes and the dynamics of the ice cover. Studies indicate that the melting of ice in these canyons could significantly accelerate the process of global warming. For example, satellite monitoring data show that the Denman ice shelf is losing around 30 billion tons of ice per year, which is equivalent to filling more than 10,000 Olympic-sized swimming pools. This raises the question of how much more we still need to learn about the hidden subglacial landscapes that could reshape our understanding not only of Antarctica, but of the entire planet. By studying these canyons, scientists are opening up new horizons for understanding the processes occurring beneath the ice and their impact on climate change. Complex drainage systems formed over millions of years continue to amaze researchers with their scale and significance for both the present and the future. In Antarctica, unusual atmospheric phenomena are observed which captivate with their magical beauty. One such phenomenon is the halo, a rainbow-like ring surrounding the sun, formed due to the refraction of light in ice crystals in the atmosphere. Halos can take various forms, from a simple ring to complex light patterns. Depending on the angle of sunlight and the structure of the crystals, halos can change in size and brightness, sometimes creating the effect of a sun surrounded by a rainbow aura. Parallel to halos, parhelia, bright light spots appearing beside the sun's disk, are frequently observed in Antarctica. These optical phenomena occur because sunlight is refracted by ice crystals forming in the atmosphere, and their intensity depends on atmospheric conditions. When temperatures drop, crystals become more stable, and parhelia can be seen even in weak light. Light pillars are another fascinating phenomenon, consisting of vertical light beams rising from the horizon to the sky. They form when light is reflected off flat ice crystals, and can reach heights of up to 30 degrees above the horizon. These pillars can take various hues and paint the ice in stunning colors, from deep pink to vivid orange, creating a breathtaking spectacle, especially during polar nights when the sun does not rise above the horizon. Scientists and explorers like Ernest Shackleton and Robert Falcon Scott often describe these atmospheric phenomena in their diaries, sometimes interpreting them as supernatural signs. For example, Shackleton, in his book The Southern Cross, noted how extraordinary and mystical the sky looked with bright light effects as he crossed the ice expanses. At times when the sky is filled with these optical effects, it seems as if Antarctica transforms into a magical world where nature itself paints pictures on the sky. Scientific research shows that these phenomena depend on the time of day and atmospheric conditions, making each of their manifestations unique and unrepeatable. For instance, at noon when the sun is at its highest, halos and parhelia can appear particularly bright and distinct, while in the morning or evening hours they can take on softer pastel shades. Some of these optical effects appear only at specific times of the year, and in this sense, Antarctica resembles a theatrical stage where each act brings something new and amazing. Observing atmospheric phenomena in these harsh conditions becomes not only a scientific interest but also a source of inspiration for researchers and nature lovers. The stunning light shows continue to attract the attention of scientists and adventurers, demonstrating how diverse and mysterious nature can be. Each of these phenomena, from halos to light pillars, is a testament to how ice crystals can transform the ordinary into something magical and unforgettable. Imagine the air as if a living entity rushing down from the high ice plateaus of Antarctica, gaining colossal power. Katabatic winds, known as katabats here, form when cold, dense air begins to move down the slopes under the influence of gravity. These winds can reach speeds of up to 300 kilometers per hour, making them the strongest surface winds on Earth. Their sound varies from a low rumble, reminiscent of distant thunder, to a piercing whistle that can cause goosebumps. At the same time, they raise snow, creating a white fog when the horizon is completely lost in a snowstorm. In such moments, the world around seems completely unreal, and the force of the wind can knock down even the most experienced traveler. These winds possess not only destructive power but also shape the landscape, eroding entire valleys down to the bedrock and creating whimsical ice and snow formations. For instance, on some parts of Antarctica, one can see ice spikes formed due to continuous erosion caused by these katabatic flows. The walls of glaciers exposed to such winds become smooth and streamlined, as if carved by skilled artisans. As a result of this process, genuine natural sculptures emerge, which can alter the landscape in just a few years. Scientific research shows that katabatic winds play a crucial role in the dynamics of the Antarctic climate, influencing temperature and the movement of ice. On November 18, 2004, meteorologists recorded a record-breaking speed of a katabatic wind in the area of the Denman Station, marking a significant event in the study of atmospheric phenomena. The constant impact of these powerful winds on glaciers contributes to their rapid melting, which, in turn, affects the level of the world's oceans. Polar night and polar day in Antarctica are unique phenomena that are difficult to imagine for someone accustomed to the familiar cycle of day and night. During the Antarctic winter, from the end of March to the end of September, the sun does not rise above the horizon for several months, plunging the entire continent into complete darkness. During this time, the sky is filled with deep shades of blue, and the night space is illuminated only by bright stars and mesmerizing flashes of polar lights, which dance in the air, creating an unforgettable spectacle. The polar lights, known as the aurora borealis, are caused by the interaction of solar wind with Earth's magnetic field, and in Antarctica they are particularly bright because there is no light pollution. In contrast, during summer, from the end of September to the end of March, the sun does not set, creating a continuous day when it is almost constantly light. The sky in this period becomes pale blue, and the sun describes circles as if bowing to the earth, not wanting to leave it. This unusualness of light conditions causes significant changes in the biological rhythms of people working at Antarctic stations, as the human body is evolutionarily adapted to a more familiar sleep-wake cycle. Studies show that constant light can lead to sleep disturbances and a decrease in serotonin levels, which in turn affects overall well-being and psycho-emotional state. Scientific stations such as Vostok and Mirny actively study these phenomena, and their staff must adapt to such extreme conditions. As a result, many of them use special work and rest schedules, as well as artificial lighting, to maintain normal energy levels and productivity. The unique light conditions of Antarctica not only shape the continent's ecosystem, but also have a significant impact on the physiology and psychology of people conducting scientific research in this remote region. Polar nights and days become a real challenge for researchers who must find a balance between work and rest in conditions where light and darkness take on forms completely different from what we are accustomed to. From an astronomical point of view, Antarctica is located in such a way that during the polar night, one can observe various astronomical phenomena, such as meteor showers and comets, which are difficult to see in the light pollution typical of most populated areas. As a result, this continent becomes not only a laboratory for climate research, but also a real observatory for astronomers. In the harsh conditions of Antarctica, where temperatures can drop to -80 degrees Celsius, life finds ways to survive. Microscopic organisms known as tardigrades are true heroes of adaptation. These creatures, measuring less than 1 millimeter in length, possess 8 legs and a bear-like gait, appearing quite peculiar under a microscope. Their bodies are covered in a protective shell, and their shape resembles a miniature bear exploring its habitat with remarkable persistence. Tardigrades can survive conditions that would be lethal to most organisms. They can withstand temperatures close to absolute zero, high doses of radiation, and even the vacuum of space. Their secret lies in their ability to enter a state of cryptobiosis, where all life processes nearly stop. In this state, they can exist without water and food for decades, and then, under favorable conditions, return to life, restoring their metabolic functions. Research on tardigrades conducted in laboratories worldwide, including institutions like Laval University in Canada, shows that they can endure conditions that would be dramatically harmful to other forms of life. In 2003, Japanese scientists sent tardigrades into space aboard a satellite, and upon their return to Earth, they were successfully revived. This discovery has shown that life can exist even in the most extreme conditions, potentially opening new horizons in the search for extraterrestrial life on planets like Europa or Mars, where conditions could be equally harsh. Scientists are confident that studying these remarkable organisms not only helps understand the limits of survival, but also provides key insights for developing biotechnologies that can be applied in various fields, including medicine and ecological restoration. Tardigrades, with their exceptional resilience, also serve as a model for studying aging and stress resistance mechanisms in other organisms, including humans. The evolution of these microscopic creatures, capable of such diverse survival, provides valuable data for further study of biological processes and their applications in various scientific fields. Imagine a continent that has become a symbol of international peace and scientific cooperation. Antarctica, encased in an icy shell, is a unique example of how countries can unite for the common good, despite political differences. According to the Antarctic Treaty signed in 1959, this continent does not belong to any nation and should be used exclusively for peaceful purposes. The treaty was signed by 12 countries, including the United States, the Soviet Union, the United Kingdom, and Australia, and since then, more than 40 states have joined the agreement. One of the key provisions of this treaty is the prohibition of military activities, nuclear testing, and the extraction of mineral resources on the territory of Antarctica. This has created an atmosphere of trust and security, allowing the continent to be studied from a scientific perspective. Scientific stations from various countries are located in close proximity to each other, sometimes just a few kilometers apart, creating a unique situation for cooperation. For example, the Moscow station in Russia and the Amundsen-Scott station in the United States are located at opposite ends of the continent, but scientists from both countries actively exchange data and research results. In the framework of joint expeditions, glaciers, marine ecosystems, and climate changes affecting the entire planet are studied. Antarctica is becoming a test site for studying global processes such as climate change and its impact on sea levels. For example, in 1993, scientists from different countries jointly studied the ice sheet, which showed that sea levels could rise by 1 meter by the end of the 21st century if the rate of ice melt remains the same. This cooperation also includes programs for monitoring the state of the environment and protecting the unique flora and fauna of the continent. Scientists from different countries are working on projects aimed at studying the impact of climate change on penguins and seals, which is important for understanding the ecosystem as a whole. The exchange of scientific information has become the basis for successful research, as each country contributes its unique technologies and methodologies. This spirit of cooperation and mutual assistance in the harsh climate of Antarctica clearly demonstrates how humanity can work together for the benefit of future generations. Antarctica is not only a unique ecosystem, but also an important example of how international agreements can contribute to peace and scientific progress. Scientific achievements on this continent not only expand our understanding of the surrounding world, but also help find solutions to global problems.